Lab Guy here. It's been a while since I've worked on this amplifier, but here's what I've discovered. If you'll recall, at our last episode, these things were shorted out. Well, it took a lot of head scratching and going back and checking my materials, and I'm going to show you what's wrong. Feel free to laugh at me all you want, because I have been punching myself in the face, figuratively speaking, and saying, stupid, 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 stupid. And here's what happened. Let's pull this out. Well, as you can see, I had a little trouble getting it out. But what it is, all right, obviously you need a bigger hammer. It boils down to the insulating pads that I've placed between the IC and the heatsink. And the problem is, they're not insulating pads. They are heat conducting pads that were not meant to be penetrated. I punched a bunch of holes in them for the leads on these chips. Here we go, it's coming out. And the problem with this material, looks like a silicone pad. It does, it looks like a greased silicone heatsink pad. Unfortunately, it's not. It's aluminum. It's greased aluminum. So I shoved all the pins of the IC through a piece of aluminum foil for all practical purposes and shorted most of the pins together. Wait a minute, here it comes. Stupid, 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 stupid. All right. Back to work. So now I must clean this crap off of these heat sinks and show you the good news. Since that day, I have been able to locate and purchase on eBay the correct 8-pin mica insulators for these National ICs. I will not reuse these two immediately. They were probably good. However, since they've been in that circuit and had miscellaneous pins, each one different, shorted out, I'm going to replace both of them just to be safe with brand new units. Not silicone. The most important spot is right in the center. That's where the heat will be, the die will be right in the center of these holes. With the grease on it, it sure is easier to see. And there we go. It's now in. I'm just going to work it around. Do my best. All right, it's greased and ready. There we go. That's one. You get into television and you will suffer the magnetic field blues. Alrighty. Good. Good. Okay then. The two integrated circuits are now installed. These are the output current feedback resistors. These two power resistors are new. They're a pair of dual 0.27 ohm resistors. The power op-amp has two pairs of power pins. One pair goes directly to the power transistors, and the other pair goes to a feedback amplifier. And this amplifier is used to cut off the main power amp when too much current is drawn. And this current cutoff point can be set by calculating a value for a resistor that you put between the two power pins. And I've chosen, by no choice of my own, to use this pair of dual 0.27s. They're a little lower in value than I'd like. I wanted 0.47s to limit the output current to 1.2 amps, 1.25 amps. This will probably be in the range of 2.8 to 3 amps. I haven't done the calculation yet. But that's okay. I don't think it'll be pulling that much current. So these are all of the main power components. This is the stuff that will dissipate heat. These two actually won't dissipate that much, less than half a watt. And so on the back side now, I have to reattach all of this wiring and tie in the two new resistors, which are located right here. So there's two channels in the amp. That's channel 1 and channel 2. And as you recall, the op amps are down here, the input op amps, and the adjusting pots for DC offset and gain, or level, whichever you prefer.
I was going to ask you about that.
There we go. Okie dokie, pig and a pokey. So we got just one channel ready to go. Should be enough for testing, huh?
Wouldn't it make more sense to get the other one set up just so that you don't have loose wires around?
No, they're not hooked to anything.
Oh, okay. Oh,
there's no power
nothing
over here.
Oh,
well,
okay.
Actually, that's not true. There's this one wire. Let me take it out. Here's red and blue. I was getting myself so confused the first time I was hooking everything up. I was just going nuts. Plus, okay, that's reasonable. Okay, not unreasonable.
What were you pulling in milliamps?
This side's pulling 100 milliamps, this side's pulling 1/4 of an amp. I don't know why.
One side's loaded, the other's not? Oh.
Nothing's heating up. Yeah, I don't. It could be out of balance. It could be the DC offset. Yep. Look at this.
Yeah, I saw
There's
it.
balance.
Yeah, I saw that.
Isn't that cool?
Oh, Oh, wow.
We're putting current into the yoke.
Oh, wow. Sweet.
Well, there's balance. So now, when I drive a signal into it from the signal generator and amplify it, we got to turn that pot all the way down. It is all the way down. That's 0 on the plus input, and now we balance the offset.
output, right.
So cool.
Yeah, that looked good, actually. At least from the standpoint
Finally,
of
something's working right. Is that thing recording? It's recording. There we go. There's ground. And we'll hook the scope to the resistor. That's the feedback resistor. Oh, I don't have a drive signal yet.
Yeah.
So this is ground. Green for ground. And red for hot.
your gain is turned down.
Everything's turned down. This gain is turned down, so I'm going to turn it to the halfway mark. Okay, I make it so the preamp is gain of 2, so the pot's set halfway. Whatever your input is what is going to come out the output. That's the thing. Okay. I don't see any signal. 2 volts. Oh, of course there's no signal. Okay, are we pulling current? Yeah.
Yes.
Okay. Where's my trigger? As I slow down, look, as I slow down it gets better. It's working! It's working!
Sweet.
Alright, we're looking at a 0.5 volt for division, so that's about plus or minus 1/2 amp of current driving to the yoke from a triangle wave from my function generator. Here's a sine wave. It looks the same. That's okay. Let's drop down in frequency. We've got some roll-off, other distortions. There we go. Okay. We'll go down here, go up. So, yeah. Oops, sorry. That's the output. And that is about 500 hertz. Well, there it is. That's one of the scan amplifiers driving the 3 ohm yoke. The next thing to try will be to connect the Vidicon yoke to it and see what the waveform looks like.